Hello there. Hi. Welcome to the second video of control system lectures. I hope you went through the first video where I taught about the basics of mathematical modeling. Not basics, I summarized mathematical modeling using an example known as shock absorbers. In this, I will continue that lesson and use a second example to help you better understand. So before further ado, let's begin. So in this we will be looking at RC circuits. RC circuits, otherwise known as resistor current circuits. So these are very common circuits. I'm sure everyone has heard of these. And what you have to understand is that at the end of the day, the process is the same. The process is the same. It doesn't matter if it's the plant that we approach in the first example or this, the process will always be the same. So let's analyze this. We have the VST, which is the power source input. This is very similar to the driving force of the first example. Very similar to the driving force of the first example. And we have the resistors and the capacitors. Very simple. And the purpose of this is to look at the voltage across the capacitor. The output, that would be this, and the input DC voltage, input of VST is DC voltage. Alright, let's begin. First, I would like to remind you guys, I will not be teaching the basics or going in depth with basics. These are summary videos only to help you with your studies and exams basically, or anyone who comes here to summarize or quickly understand the mathematics, deep complicated mathematics. So know your basics before you go through these videos. So apply Kirchhoff's law. Kirchhoff's law here, and I'm sure everyone understands Kirchhoff's law, which is you cannot create or destroy current, or what comes in equals what goes out. Or if you use mathematics, Kirchhoff's current law, the summation of nodes of I equals 0. Very simple. So what is how do you apply Kirchhoff's law here? So I1 equals I2 plus I3. Very simple. I2 plus I3 equals I1. Very simple. Now you define the current across each component. Now each component has its own characteristic personality, and this personality is unique for each component, and you should know these behaviors of each component when current passes through. And these are again basics or fundamentals, so you should know your fundamentals. And yeah, let's begin. Current across the resistor, Ohm's law. So apply Ohm's law. Current across capacitor is capacitance into rate of change of voltage. And again Ohm's law. Very simple. Let's clean this up. So what do I mean by clean this up? I hope you remember from my first video, I explained that all dependent variables and their derivatives have to be on the left hand side. So that being said, let's clean this up. oops, sorry, I made a mistake. R1, yes, okay, and let's clean it up further. Okay, so these are constances, you know that, because capacitance is a constant, resistors are constants, and yeah, this is the system model. Very easy. System model of RC circuit, very simple. And let's take a few steps back. There's something I want you to see. Let's get rid of all of this, get rid of this, and get rid of this, and let's go back to the first example. Just to recap, we have the shock absorber with the spring and the damper, spring constant and damper. Okay, so there is this similarity of this and this and this. Oops, it's not that clear. Let me rewrite this, it's not that clear. Okay, this and this and this. Now, what does this tell you about these similarities? And what we learn from this is that whatever system we deal with, whether financial systems, social, or engineering, doesn't matter, because when we bring them down to mathematical models, your perspective will have similarities. So what do I mean by this? You won't see capacitors and dampers after you bring them down to their essential mathematical models, but what if you take the initial components, what you will always end up with is a differential equation with similarities. And when you see these similarities between these equations, you see the beauty of mathematics. And this is how you should study. You should see these patterns, you see these similarities. So something to keep in mind as an extra thing. Alright, let's summarize. System models are ordinary differential equations. You know this, it should be by heart by now. System complexity is represented by model order. So what do I mean by this? First order RC circuit, second order shock absorber. Now both questions examples was not that difficult, but the ordinary differential equation which we formed have their own level of complexity, and second order is usually more complex than first order, because once you try to simulate these, second order will be harder to approach. Something to keep in mind. The response output of a plant can be obtained by solving the model ODE. So this is pretty straightforward. So when you take the system model of the RC circuit, and so what this basically says is that when you have a non-input, when you have the input, say in this case a DC voltage, you will get your output of that ODE. So it's pretty straightforward. But now, what is Laplace? So Laplace, so if you take the system model, just the system model, it's pretty much useless. What do I mean by this? So if you ask me to calculate the distance traveled by a damper, or in this case your main objective, time taken for a capacitor to build up, like I won't be able to do it. because what you need is not the system model in the end. What you need is the system response. What you need is this, and to calculate it you need Laplace transform. So what does a system response look like for a RC circuit for that specific equation which we discussed before? It will look something like this: a function of time where right hand side is this and left hand side is the output. And it's what happens when you solve an ODE, when you solve an ordinary differential equation, and you do that with Laplace. It's easier with Laplace. There will be a bit of challenge. Most of you know this. First order is actually easier than second order, and which is easier than third order. So the level of difficulty proceeds as you go, and eventually it might even become impossible, and you might need to use MATLAB. So in the next video I will teach you or show you actually how to solve a system response, how to solve an ordinary differential equation of the RC circuit and get the system response. But before you go to that video, please look into your basics in Laplace. I will not be going in depth in Laplace. At least I will not be going in depth in this video, maybe in a future video. But what I will be teaching is the system response of RC circuits using the Laplace table. So if you know your Laplace table, the basics, please go through it. And yeah, I will see you in the next video. Thank you, and please subscribe and share my channel, so it will be really helpful and support you. Thanks guys.